Okay, welcome to this kind of revision session. First of all, subscribe to the channel, share this video with someone who might find it useful, and leave a like before we begin. So today we are going to talk about momentum. We are going to talk about momentum. So yeah, today we are going to talk about momentum, and more specifically like linear momentum. So this is the momentum of an object traveling in a straight line. So in secondary level and high school level, you will never be asked what momentum is, but I'm gonna tell you today. Momentum is kind of the measure of the ability of an object to change the motion of another object. Yeah, it's a lot to take in. Don't worry about it, it will never be asked. So we have a formula to calculate momentum. Momentum is represented by letter P. Okay, that's it's a small letter P. And they say that the momentum is equal to the mass of an object multiplied by its velocity. And momentum is a vector quantity. So it's a vector quantity. It's a vector quantity. It has both magnitude and direction. So yeah, from this formula, this m apparently stands for mass. That's on your level. It stands for mass, and this is just the velocity of the object. And more appropriately, this m just stands for inertia, not mass. It's just inertia, but you can use mass for now, but if you are going to pursue physics in tertiary level, this will be inertia. So the SI unit of momentum is kilograms meters per second. Like, it's just the SI unit of mass, which is kg, and SI unit of velocity, which is just meters per second. Now let's do an example. On this example, let's say this is a bullet. It is traveling at 5 meters. It won't be realistic. Let's say 500. Okay, 500 meters per second and it's traveling east. Okay, and the weight of this bullet, let's say it's 50 grams. So they ask you to calculate the momentum of this bullet. So the momentum of this bullet is, like I've shown you, it's P equals mv. So it's the mass multiplied by the velocity. So the mass that we're given here, I meant to say 50 grams. So the mass we're given here, it's in grams, so we need to convert it into kilograms. We just divide by 8,000. Okay, and then the mass is just 50 multiplied by 10 to the power minus 3 multiplied by the velocity of 500 meters per second. So the momentum of this bullet is 25 kg meters per second. And don't forget the direction, because this is a vector quantity, so the direction is the direction of its velocity. So it was traveling east, so it will be the direction of east. Another example right here, we have a 10 kg crate. It's traveling also east, but at a velocity of 3 meters per second. I said it's 10 kg. So the momentum of this block is just equals to the mass multiplied by the velocity. So it's just 10 kg multiplied by 3. So the final answer will be 30 meters. Will be 30 kg meters per second. Okay, so that's it about momentum. One thing I need to say before I end this session. So the conservation of linear momentum, just cram this, just cram it. It says the total linear momentum of an isolated system is conserved or remains the same. So they're saying the initial momentum of a system like pi is equal to pf. A system is like if you say someone right here is riding a skateboard, let's say. So they the total momentum at the beginning of the journey and at the end of the journey will be the same. Yeah, so that's what conservation of linear momentum is, but I got to end it now. I will explain later if you don't understand, and please subscribe. Bye.